Hello, and welcome back. We're
Yes,
moving on.
we are moving on
to the next module here, Module 3.
Yes, that's still Jeremy Foster. I'm still Christopher Harrison.
That is still who we are. In this module, Module 3, we're going to move on and talk about asynchrony and concurrency.
That's a couple of fantastic Scrabble words.
Yeah.
Although asynchrony wouldn't work because you've only got one Y and that has two.
I'm surprised you know that much about Scrabble. That's awesome. We're going to talk about two concepts that are related and often confused. We're going to be talking about asynchrony and concurrency. And with these two topics, I have a question for you.
Okay.
Why are these such big topics? Why is this such a big deal?
That's a fantastic question. And it really kind of comes down to two big things, again, differentiating between the two. One of it is to make sure that our interface is going to continue to be responsive. So that way our user can actually move the window around, maybe hit cancel, something like that. And then the other one is because of the fact that multiple cores is now the norm, that you're not going to be able to run out and buy a system anymore that doesn't have multiple cores. And if the system's going to have multiple cores, it's sort of begging for all of those to be used. So let's use them because that's going to help improve the performance of our applications.
So that answers the question of why asynchrony specifically is an important topic, but it seems like it's gotten increasingly more relevant or more important, and we've been focused more on it. And I wonder if you have any speculations as to why that is. Has the need for it increased, and if so, why?
I think it's a little bit of both. I think part of it is the need has increased, that it really is just, it's expected now that this is going to take place. But I think the other thing is, in a lot of ways, it's become so much simpler that trying to handle making sure that my application is going to be responsive, especially when you're talking about something like WPF, where I always need to get back to the main thread, or the whole concept of begin and end and having to pass along the state object because that was now going to be out on a separate thread. So that way we could actually, do something like get the data reader if we were going to be doing an ADO.NET query. That those types of things used to be a lot more complex. Now it's become much simpler than it ever has, and I think that's one of the biggest reasons why it's become such a big thing today.
Yeah, I think that's really true. I think there was a real pain point there where I would say I remember working on greenfield applications where I would say, all right, V0 here, I'm not going to worry about it. I'm just going to do it, and there might be some delays.
Yep.
And then when I start working on V1 or V2, maybe I'll implement this begin and end pattern and get into asynchronous patterns. So yeah, it seems like it's all the rage these days, and I think you're exactly right. It's easy enough that we can that in V0 we can go ahead and put asynchrony right in.
Yep.
So let's go ahead and deobfuscate these terms.
Well done.
The first term, asynchrony. What is asynchrony and how does it differ from concurrency? Because they are sometimes confused. What I'm showing here is, let me bring up a pen just so I can show properly. This is kind of the before and this is the after. Before asynchrony, we have something that is a blocking event.
Yep.
Now, who knows how much time that is, and it depends on your application how much time matters.
Yep.
But it's a blocking event. It might be blocking you for 500 milliseconds, or it might be blocking you for 7 seconds.
Yep.
Who knows, and who knows what the thresholds are for your users. We ideally don't want to block at all.
Right.
We've got ourselves a blocking event, so we implement asynchrony to basically manage our pipeline better.
Right.
We've got a thread, and we've just made a call that is going to take X number of seconds. What are we going to do during that time? Are we going to wait?
Yep.
Put everything on hold, block it entirely. It'll be done soon, I promise.
Yep.
And basically bring the UI to its knees?
Yeah, and that's just not going to be a good experience at all. The analogy that I always like, if you don't mind my throwing in an analogy here, is my favorite dish to cook at home is chicken cacciatore. It's what I'm famous for. And so the step one of that is to brown chicken. Now, of course, you still have a whole lot of prep work to do because you got tomatoes to chop and onions to chop and mushrooms to chop and all that good stuff. But I also have to brown this chicken, and that's going to take 5 minutes or so each side. Well, I don't want to sit down and, all right, well, let's start browning some chicken and then wait. And then we're going to turn that over and then wait, I could be doing other things. So let me just go ahead and brown the chicken. Let me just get that rocking and rolling. And then I'm going to go over here and I'm going to start doing my prep work. And then I can go ahead and turn over the chicken, and then I can keep doing other things. And that's basically what we're talking about here, is we're allowing the application to keep doing other things while we're waiting on that long running thread.
Yeah, absolutely. So let me get this straight. All of this coding experience, and you're famous for your chicken cacciatore.
I am famous for my, yes, yeah.
All right.
Yep.
All right,
yeah.
cool.
Yes. If you were ever invited over to my house and I cook dinner, I can guarantee you it's going to be chicken cacciatore.
Okay. Yep. All right, great. I'll take you up on that. Next time I'm in San Diego.
Excellent.
All right, so we have a blocking thread. Yep. We just make better use of our time. We do something while it's working, but we're still predominantly talking about a single thread. Now, that's not to say that another thread might not be used for that other task. It might, but we don't have to worry about that.
Right.
As far as we're concerned, we're just managing our one thread or our one stream better. So that is asynchrony. It's a disconnection from what happens in one method call from what might happen going forward.
Right.
Now, concurrency, also called parallelism, is, here's the before. The before is that we've got one single thread in time, one core doing one thing. This is how I work in my life. I'm single-threaded.
I use that exact same joke all the time.
Yeah. About me?
Well, yes.
And then the after is that we now have literally two different things going on at one time. This is installing a second clothes washer in your house. Okay?
Okay.
I can now wash two completely different loads at the exact same time. I am twice as efficient. This is building a new lane on the highway. Twice as many cars have the ability to go through in that section.
So, of course, 4 times as many cars show up, but that's really
true.
Different conversation.
Yeah, that's a completely different conversation. Now, the same thing that affected us in the asynchronous realm, which is it used to be harder, so developers were more tended to leave it on the wayside for now.
Yep.
Has affected us with concurrency. It's been possible for some time to spin off threads,
absolutely,
task things to those threads, manage them, switch back and forth. We've had that function for some time, but we didn't have so many cores, so not many software applications needed that functionality, and it was hard.
Yes.
We didn't want to do it, especially in V0, 1, 2, 3, or maybe 4 of the application.
Yeah.
But there are a lot of features that we're going to see right now that make it drop dead simple.
Yes.
So let's move on. Let's do exactly that. Asynchrony and concurrency. Let's start with asynchrony. Treat these as separate topics. And let's first jump into JavaScript. How does JavaScript handle the concept of asynchrony? I'll just answer my own question. Promises. That's the answer to the question. Promises, what are they? They are a placeholder in time. They're a way of saying, I'm doing something now. I'm going to come back to this, but I need to move on. So I'm browning the chicken, but I've got to go cut the mushrooms. I'm going to come back there to that place in time, to that stove, where I can finish the browning of the chicken while it's working on it. So this all centers around functions. Functions are either asynchronous functions or they're not. They're synchronous functions. And if it's an asynchronous function, then when you call that in JavaScript, it always returns the same type. You know how functions might return an integer, they might return a string, they might return whatever, and in C# you strong type that, you determine what it's going to return to you. Yep. And in JavaScript you just say, it's going to return something, or it might not, whatever it wants to do.
It may or may not.
It may or may not.
They just, whatever.
That's how we roll in the JavaScript world.
Yep.
Well, if you're doing an asynchronous function, you must return a promise. That's what you always get back in JavaScript. Now that promise object is probably going to have some return results inside of it, but it's a promise object. And when Christopher's talking about C#, he's going to tell you what the mapping is, or the analogy is in the C# world. But in JavaScript, it's a promise, okay? Now, the important fact is that promise comes back to you right away. You get that now, okay? So I go and put in the chicken, and I get a virtual promise that there's a placeholder here. This task is going to be worked on while it's, as long as the burner's on. And then as soon as it's done, we're going to come back to this point. We're going to come back to this promise, okay? Now, promises, the concept actually come out of the common JS spec. So there's a spec for how promises should be written, and then they're implemented in many different libraries, okay? If you're working in on the web, there's a good chance that you're using jQuery. A lot of people are. And in jQuery, we have this object called a deferred, and deferreds have promises. They can return promises from from functions that created deferred. And so that promise object, as pretty much as it's spec'd out in the CommonJS spec, is instantiated in jQuery. They're also available in the WinJS library if you're creating a Windows 8 app using JavaScript. So if you want to work with promises, you've got that. It's built for you and it adheres to the spec. And they're also built for you in a number of other libraries. And one of them that I'm going to show you is a library called Q. Q is a fairly popular promise implementation. If you don't need the whole jQuery dependency and you're not working with WinJS, all you want is promises, Q is a pretty good way to go. Okay, so let's have a look at some of these. Why do we need another solution for handling asynchrony, where JavaScript's been able to do asynchrony before we had promises, but what we're trying to do is alleviate what has come to be known endearingly as the Pyramid of Doom. So we have...
we need dramatic music at this point.
Dun, dun.
Thank you.
Cameraman, cue in dramatic music. So the Pyramid of Doom is a structure that ends up looking something like this on the screen. This is a relatively simple instantiation, but you very well may have code embedded in each of those steps, and so this becomes a gigantic mess of spaghetti code that nobody likes to look at, especially the guy that comes after you who wrote the code. So what we're working with here is the classic callback. I'm calling a function and I'm telling it, here's the function to call when you're done. It's a callback function. And if you do those nested too many times, you end up with a pyramid. It's pretty awful. Enter promises. Promises are going to fix that. Now, I'm going to show you a demo to help to communicate the concept of promises. And I'm going to show you this demo in a new environment. As opposed to showing to you in CodePen.io, I'm going to show you these in CodeShow. Now, CodeShow is an app that I wrote some time ago that is a Windows 8 app, and it's intended to teach you how to make Windows 8 apps using HTML and JavaScript. So it's a little bit recursive there, and we as programmers like recursion. So I'm going to go ahead and jump into CodeShow. As you can see, I've got it right here on my start screen. So I've installed the Windows 8 app of CodeShow on my start screen. I'm going to go ahead and launch that. What's a start screen? That's different, isn't it?
That's something completely different. Yeah.
All right. So when you open CodeShow, you get this hub experience, and it shows you a few of the latest demos, but then you can click on demos to drill into the big list of all of the demos. All right?
Nice.
Now, one of those demos is called Promises, and you can look at these alphabetically, or if you're back on the main hub, you can click up in the search, or you can actually just start typing. That's kind of the good pattern, is if you don't need the keyboard for anything else, then give it to the user as a way of automatically jumping into the search. So I search for promises, I come up with promises, and here I am in the promises demo.
Okay.
Now, the intent behind CodeShow is not to just show off certain things that can be done, but show off how you do them. So for any demo, you can look at it and see it work, but then notice on the top here I have see the code, and then it toggles between see the code and see the demo. So I can click on see the code, and it shows me the HTML, the CSS, and the JavaScript, and if there are multiple JavaScript files for any reason, it shows me all of that. So you can go install CodeShow right now for free, and you can see all of these demos, and the ones that I'm showing today and the ones that I'm not, and all of the code behind them. So let's go ahead and look at these demos. Now, excuse me, the first concept is really the placement of promises and what this does for us. The first task that I'm going to be calling is a long synchronous task, all right? Now, I'm going to touch that start button here, and when I do, my UI is going to freeze because I'm doing something for 3 seconds, and I am not returning a promise or doing it in an asynchronous fashion.
Okay.
So let me go ahead. Here we go. Start. Now, notice that it's frozen, and I tried to hit the back button, and nothing happened. Oh, and then finally it woke up after 3 seconds, and it obeyed me and went back.
That's a bad interface.
Not exactly the experience that we want. Start, and then, okay, now I'll return and do something. Not exactly ideal. So we want to get asynchronous. So on the second one, I've implemented asynchrony, but without promises.
Okay.
Now, this one is going to work. It's not going to block our UI, but it's going to lie to us. I'm doing something for 3 seconds, and this is telling me that it's immediately done. I don't want to lie to the user and say that it's done when it's not. That thing was still working in the background.
So give us progress bars that actually mean something.
That actually means something.
Hey.
Do it right?
Hey.
So enter the third example here, a long async using a promise that's going to tell us when it comes back, when it's done.
Okay.
And in fact, this one not only tells us when it's done, but it tells us along the way as it's working on it.
Okay.
So I'm going to hit start, and you're going to see that progress bar not just complete in 3 seconds, but advance every second along the way.
Nice. Okay.
How is that done? I'm glad you asked. See the code?
How is that done?
I'm glad you asked. See the code, and here we go. You can look at all of the code right here. Okay? So that's promises. That's the concept behind it. How would we use that? And really, this just looks like the same demo over and over. 3 seconds later, the progress bar completes. The purpose for this is to hit see the code and look at the code behind this. Sometimes you just want to consume a promise. Sometimes you're wanting to pass on a promise. In other words, you're writing a function that you want to be asynchronous and it's calling a function asynchronously. So your function's calling the database. It could be blocking for some time. So you're going to get a promise back from this database call, and you want to return a promise to the user so that they are notified that they're waiting for something. And finally, the concept of chaining promises one to another. This is going to call a promise and then complete it and then do the next promise and then do the next promise and so on. And you can go behind and look at the code for that. All right, so that's the code show demo of promises. And I just drew on my screen. Let's try that again. Hey, not what I intended. Now I'm going to show you the CodePen demo of promises. So we're going to jump back out to CodePen, and upon special request, we've made CodePen white now, so it might be easier for you guys to see. Hopefully you agree.
There we go. Yep.
And we're not going to be concerned with the CSS here. We are concerned, actually, let's look at the CSS for a little bit, because as you can see, my output window has been stylized now. I've got a background that is light gray. I've got a certain height and a larger font size. I'm using a special Seago WP font that you see all over in Windows applications. And for my button and my progress bar, I'm doing quite a few styles just to make this look nice. If that's fun to look at,
Absolutely.
then great. It doesn't really add to the functionality, but there you go. But essentially what we have is 2 buttons and a progress bar. Minimize that, and let's just look at the JavaScript. Now, this JavaScript is going to use a queue. Queue comes from a library, and you might wonder how in CodePen I brought a library in, and you do that by in the JavaScript window going to the tools, and you can very easily turn on CoffeeScript or LiveScript. You can very easily bring in the latest version of one of these common libraries, or you can specify a live URL to some other library that you're interested in. And by the way, it links you right out to the CDN.js. Have you ever heard of CDN.js?
Just in passing.
Yeah, it's basically a big enumeration of all of the JavaScript libraries delivered by way of their CDN. So you can just grab this URL and use those in your application. So really super handy.
I like it.
So what I've done is I've gone out to CDN.js and found the queue. Let me just show you that. I've found quite a ways down here. Let me do a search for it. That would save us some time. Search for the queue library, and sure enough, I find, once I get past all of the
ones you don't want.
Ones I don't want, and I find QJS. And here we go. Here is the CDN address directly to the minified version of QJS. I bring that in, paste it into my JavaScript window, and now suddenly Q is available to me. Okay, so here's what we're doing. Once again, I have a output function, so anytime I type output, I'm going to be printing that to the screen with a break at the end. Pretty simple there. I'm going to, in my go on click, so whenever I press the go button, the first thing I'm going to do is this one, and because it returns, this is the only one that's relevant. And then we're going to move on to these other examples, okay? But for now, just pay attention to the first one. I'm just going to set the progress value to 100. So I'm directly changing my progress value. Go. Now notice that there was an animation that was associated with that. That's because I'm using the progress control in HTML, and Internet Explorer automatically animates that progress control.
Okay.
So that's pretty slick. Okay, so let's go ahead and comment out this first example and implement the second one. It's updated for me. Now what I'm doing is I'm calling a very simple async method. And look here, then. So this is the core concept in promises, and that is that promises are what are returned from an asynchronous function, and promises implement this then method. You can always call then on a promise.
When?
And anytime you want, you can call then, and then you can call then again. That's when. So when I call then, I have the opportunity to specify 1, 2, or 3 functions, the first of which is what to do when this thing's done.
Right.
This is the success function.
Okay.
I could also pass in another function that is the the error function. What to do when this promise errors out.
Okay.
Because it might. And then the third one, which is also optional, is what to do when this thing reports that it has some progress. So just like my example that showed the progress of that progress bar. In this case, I'm only doing something whenever the promise is fulfilled. So let's go look at simple async. So here's my simple async function, and it looks like I've accidentally typed Q twice. That was going to mess me up. I'm glad I spotted it. I'm creating myself a deferred. This is a Q concept. It's also a shared concept in jQuery. I'm creating myself a deferred. I'm immediately resolving that. I'm not really doing anything. I'm just immediately resolving it, and then I'm returning the promise object from that deferred object. So this promise is being resolved immediately. It's not taking any time. So if I run this now, it just immediately updates my progress bar. And finally, I'll move on to the last one, which is my long task async. So let's go ahead and comment out this one. And now it's going to only pay attention to my long task async. And when that long task async is done, then this is going to happen. It's going to complete my progress bar. So let's look at the long task async. Sorry, not that one. The long task async is implemented down here. In here, I'm specifying that I want to wait for 5 seconds, that I want to create a queue defer, and then I want to do a loop using the window set interval, which is going to wait some time. It's going to do something every X number of seconds, or every second up to the number of seconds in my seconds delay. So it's going to do something every second from 0 to 5. And on each one, it's going to do a denotify. That's reporting progress.
Okay.
And at the end, when we're done, it's going to resolve that promise. Okay, so this is pretty simple code. And then, by the way, it returns that promise. So all of this happens later, not immediately. This happens immediately. We come back from that function with a promise in hand. Okay. So now when this one is ready, now I get that functionality that we're expecting. I get the functionality where it reports its progress every second. And in fact, it didn't. And I'm not sure why. And we won't troubleshoot it. But it does, in fact, report its progress after 5 seconds. But I was fully expecting it to increment every second.
Right.
And it just didn't.
We're really cooking on this show.
We're really cooking on this show. Back to the chicken cacciatore. Okay, so that's basically how you implement promises in JavaScript. I've shown you in 2 ways. You can go download CodeShow if you want to look at that one offline, and you can go to that CodePen if you want to look at that one offline. And then the next topic that we're going to be looking at, are we going to look at concurrency? Yeah, I think we're going to look at concurrency in JavaScript. Yeah. So concurrency in JavaScript it's a super simple concept, or super simple implementation rather, of the concept of doing 2 things at once. Now, first of all, in JavaScript, depending on your engine, it may already be doing 2 things at once, because I know in the Chakra engine that sits behind Internet Explorer, back at Internet Explorer 9, they started implementing some built-in logic behind when do we figure out that we can do things in multiple threads and make this faster for the user. So some of that's automatically happening, but not for your code, okay? So let's go to the web worker sample. And in the web worker sample, I'm making this look really simple, okay? And I'm doing this by creating 2 things, a boss and a worker. So this is just a visual right here. This is just a graphic, but I'm going to show you the code so you can see what's going on. The boss is your main thread, your UI thread. The worker is a separate thread, and you can spin up multiple, but in this case, I'm only doing 1. Now, in this interchange, here's what's happening. The boss is saying, hey there, worker, sending him a message, like I'm passing him a value. As soon as he does that the first time, passes him a message, the worker comes to life and says, I need to do some work, so I will become an entity. I will rise. And the worker in this case hears the boss and responds to him and sends a message back up to the boss and says, hey boss, I heard you say, hey there worker. In fact, he has access to that message that came down, and he's proving it by reporting it back to the boss, okay? Super simple scenario. Let's go see how we implement that. So let's go to first of all, the web worker JS code in here, which shows you how, this is essentially the boss JS. This is the main JavaScript. And what we do here is we implement this worker, which is a new worker. Okay, we're creating a new worker. That's an object that's available to you. And when you instantiate that, you pass it the URL, the relative URL of the JavaScript that you want to run in that separate thread. So in this case, our separate JavaScript, our worker JavaScript, is called task.js.
Okay.
And so we're instantiating a worker, pointing it to task.js, and now the first time we call that, it's coming to life, and that's what's happening down here. So we're saying whenever, that's what's happening right there. On my worker, whenever a message is sent to that worker, here's what I want to do. I want to say, the worker said. So then the boss can call the worker and post a message. I'm sorry, I said that wrong. Let me correct myself. This is the boss's response to when the worker posts a message back to him.
Right.
So let me rephrase that. This is the worker saying, hey, or the boss saying, hey worker, I've got a message for you. So it's calling, this is a keyword, it's calling the post message method of the worker and passing in this value. Now we need to go look at the task.js. This is the worker code. Now this is kind of interesting. Normally when you're working with JavaScript, you're working with this big DOM environment. You've got access to the window method, the global method, all the global variables, the whole DOM. That's what you have access to. In this case, you don't. You have a limited set of things that you have access to.
Yep.
Because essentially, you're going to be doing some disconnected work. You're not going to be accessing the UI thread. If you need to access the UI thread, you need to talk back to the UI thread by way of messages and let them do the updating of the objects in the UI.
Right. Okay.
So this is the worker, and he's responding to an event. That is, whenever the message event is called on himself. So self on message, I have a function. This is what I want to happen. Whenever I get called, pinged, messaged, I want to send a message back to the boss. So he calls post message and says, hey boss, this is what I heard you say. And just for reference, I put that data package in there so that goes back to the boss. Okay? Now you as the developer can rest assured that everything you put in this web worker method is going to happen on a separate task. And that's the way we implement concurrency in JavaScript.
Okay.
So does it work differently in C#?
Well, if it didn't, then I wouldn't have anything to talk about. So of course it works differently. So, let me get back one more slide here before we take my slides. There we go. That's where I want to be. Cool. So in .NET, what we wind up having is an object called a task. And task really is the heart of any form of asynchronous programming, concurrency or otherwise, inside of .NET. Now, what we're going to see is that our tasks are going to be wrappers for methods. So I know that I've got something that is going to be long running. I need to go contact a web service. I need to just execute some long running code. So I can call that with a task, and that will automatically then be placed out onto a separate thread. And then I can go ahead and start to use that to figure out exactly where and when I want that to execute. So if I kick over to Visual Studio here, and let me come over here, that's perfect. What you're going to notice is I've got a little WPF app here, where there in the middle, you're going to notice that I've got my little app and all of my little buttons with all my little demos wired up. Now, what I want to do is highlight a couple of real quick things here. Number one is the simple fact that you are going to notice that this little application could probably stand to use a little synchronization, a little bit of locking, and all that good stuff. I'm trying to keep this simple demo, so I didn't worry too much about getting in and doing that. Yeah. The next thing that I want to highlight is just a little bit of helpers that I've got up at the very top here. So you're going to notice that I've got a new random object, and that's going to be used with my little sleep helper method. And that will automatically sleep somewhere between 1 to 2 seconds. So just give us some amount of time that it's going to go ahead and sleep. You're going to notice that I've got our little list of members. That member class I actually just copied and pasted from before. And then you're going to notice that right here, I've got my little helper methods to clear the output. So that will clear out the little list box that I've got, and then add in a brand new item into there. So there is my little helper behind the scenes. Well, let's start off with that no threads click, and you're going to notice that here what I'm going to do is I'm going to clear out the output, and then I'm going to call this little do work method, Alt F12, I love it, that little do work method, which is going to go call another little helper method here called get message. And I can't do an Alt F12 from there as well. So let me just bounce into it. So let me just say F12, and then our little get message F12. What this is going to do is it's going to sleep, and then it's going to return back something that I use quite frequently whenever I'm trying to demo anything that involves threading, is let's just go get the current thread's hash code. That's just a very simple way to go in and indicate, hey, look, we're on a different thread. Rather than having to worry about going in and naming things or anything like that, let's just grab the current thread. So you're going to notice that this is going to sleep for 1 to 2 seconds, and then it's going to give us some text back on thread, and then whatever thread it is that we happen to be on. So in the case of my little do work, if I just scroll back up to the top there, what that's going to do is that's going to call that get message, and then it's going to display that out. So if I run this, what you're going to notice is that the first time through, I'm just going to be doing do work, do work, do work. So I'm just telling it right then and there on that main thread, let's go ahead and do work. And when I do that, you're going to notice everything freezes. Oh, now it finally finished. So it took a little while to get there, but it finally did finish. And you're going to notice that it told me each time that it was on thread 1. By the way, just a little side note, if you were trying to improve the performance of this application, just a little tip, take the sleep calls out of it. So just a little performance tip. So in any event, you're going to notice I went in, did that without threads, everything froze, everything locked down. That's obviously not what we want. So now if we come back and we go ahead and hit run tasks, now what I want you to notice is that sure enough, my UI is still going to be responsive. Here, let me do that again. And all of those then executed on separate threads. And what's nice about this is that I don't have to worry about managing any of these threads. That's usually one of the biggest problems, and it's a lot of power that we don't necessarily need. So all I have to do is just simply spin off the threads, it will go off, do its own little thing, and I then don't have to worry about it. Now, what happens if I'm looking to break things down a little bit? Now, one of the things that Jeremy talked about before was the concept of a promise, where I know that this is going to go off, it's going to do something, and then eventually give me back a value. Well, maybe I want to do something once I finally get that value back. This is where continue with comes into play. So if I bring up my continue with, and by the way, this is one of a couple of ways that we can do promises. If I bring up continue with, here's what I want you to notice. I'm first creating a little task, and my task is pointing to get message, which by the way is one of two ways, or one of a couple of ways that you can set up tasks. So you're going to notice, and I've actually done that up here with my do work as well, just to step back a little bit, is that that's now pointing to that little do work method, which I've got right down there. And you're going to notice that right in here, here we go, that there is my little get message, and that's going to be pointing down to our little get message method down below. Well, if we remember, he said in English, if we remember, what happens with get message is that it's going to pause for X number of seconds, and then it's going to give us back that message. So what we want to do once we finally get the message back is then pick up where we left off. And this is where our little continue with comes into play. So if we come back in, what you're going to notice is that we've got our continue with. And our continue with is now going to say, well, when that's done, then let's go ahead and execute this code right here. And you're going to notice that I'm going to get the parent, and that parent is going to be that task. So in other words, what's going to happen is this task is going to execute. Once it's done, an instance of it will be passed into here, so I can go grab that result. And so that's one way that we can do promises. And so the output here, whoops, I didn't hit F1, but apparently I did. Control F5, there we go. When I do my little run promises, you're going to notice it's just going to tell me the thread that it executed on. Okay, now let's get in and take a look at async. So give me a second to switch back to a slide. And I want to be here, there we go. Let's talk a little bit about asynchrony. So again, we've got our little scenario that I know I've got to brown a bunch of chicken. That's going to take a little while. I've got other things I want to chop up. So let me just go ahead and put that off over here, and let me keep doing whatever work it is that I might want to do. That's exactly where async and await come into play. So what this will allow me to do is this will allow me to say, all right, well, I've got some long-running thread. I know I've got something that's going to take a little while. So let me go ahead and start that cooking. And then what I'm going to do is I'm just going to continue my work, whatever it is. And then finally, down here somewhere at the bottom, I'm going to say, okay, now it's time for me to go check on the chicken. So now let's go ahead and wait for that to be done. And that's what it's all about. It's all about getting in there and saying, okay, well, I know I've got this long-running operation. I know I've got some other work for me to do. Let me go ahead and start that, put that over there. Let me keep doing my other work. And then we'll go ahead and get the result back when we're done. Now, the couple little things that you will need to keep in mind about using async and await is that, number one, the method that we're going to call that contains the code needs to be decorated with async. And then number two is if you are going to use the await keyword, you also need to use the async decorator. Let me kick over to my code here, and let's show this off inside of here. So there's my little button await click. And what I want you to notice is right up the very top here is I'm going to clear out my output. And then I'm once again, just like before, going to set up my little thread, my little task, and then I'm going to call start. So nothing that we haven't already done. In fact, we had that right up top here that I had the exact same thing, clear output, get our task, and then call start. So I'm doing the exact same thing. I'm clearing the output and I'm calling start. That's where I'm now going to put the chicken on the burner. I'm just going to beat this analogy into the ground. So that's where I'm going to go ahead and put that off to the side. Now I'm free to keep doing whatever it is that I might want. So I could go in and say, add item to output, running task. And then what I can do is say, all right, well, now I'm done doing the other things that I needed to do. Let me go ahead and grab the results. And that's where this await message task comes into play. Now, the biggest thing that I want to highlight right away about this, because this confused me at first when I first saw this. Await is a blocking operation. And a lot of the examples that you'll see will say something like task start, await. Well, that's not necessarily how you're going to go off and do things. That quite frequently, what you're wanting to do is other work. So you can do your other work, you just do it right after you say start. So you go in, you say start, you do your work, and then once you're done doing whatever else it is that needs to be done, then you call await. And then I'm going to go ahead and display out my result. Now, before I show you the fact that this is going to display out running on task, whatever it is, I want to highlight one last little thing about do work, which I put up to the very top here. And this is one of the biggest challenges in working with WPF or any environment that requires that the main thread be in charge of the UI. So this is one of the things that Jeremy had highlighted earlier when you're using a worker, that in order for the worker to update the UI, the worker needs to signal back to that main thread, as it were, hey, here's something that I now want you to put onto the UI. WPF behaves the exact same way, that WPF will only allow the main thread to update the UI. So if we kick back to the code here, what you're going to notice is that I kick back to the main thread by calling dispatcher begin invoke. And I got to tell you, after a while, that just becomes a hassle every time having to call that dispatcher begin invoke. Well, you're going to notice here that I don't have that. that you're going to notice here that I said, all right, well, go off and go do whatever it is that you're going to do. Let me go ahead and do my little bit of work. And then let me go ahead and grab the result. And then let me go ahead and update the UI. So everything that I'm writing in here is on the main thread. The task is going to be on a separate thread, but everything that I'm writing here is on the main thread, so I don't have to worry about kicking back into the main thread by calling that dispatcher begin invoke. So again, fire up my app. Or maybe I didn't close it from before. I didn't. That's okay. There we go. That'll eventually fail out, and that's okay. Let me just go ahead and click on my run await. There's my running task, and there it is on thread 8. All right. Well, that's all well and good, but it's yelling at me because I still had it running in the background. That's all well and good, but what happens if I want to create a method that's designed to be asynchronous? So rather than having the caller worry about, setting up that little task and doing all that nonsense, how about we just create the method right away that can do that for us? And that is what we can absolutely do, and I've got right down here. Now, here's what I want you to notice. Right here you're going to notice I missed a little bit of refactoring when I was building this demo. There we go. Here's what I want you to notice. Right here and right here is the exact same code. Nothing different. But you're going to notice that on the bottom one, what I've done is I've wrapped that up inside of a task, and then I returned that back. Now you're going to notice that I've got that flagged as async, which is going to be the indicator that, hey, this could be used with an await. You're also going to notice, by the way, that anytime that I call await, I also need async. And then you're going to notice that I can just go ahead and call that just by saying right there, get message async. And by the way, one little convention, if you ever do create an async method, you do want to end it with async. On a related note, anytime that you're going through the framework and you see something like open async, the one that says async is the async one, the one that could be used with await. And so now, once again, I go back to my little bit of code, run my async method, and now I'm going to get the exact same response. Cool. All right. Well, how about threading? It's a good question. Let me go back to my slides here real quick. There we go. And I want concurrency. Cool. So
now, Christopher, one of the questions in the chat room is the difference. What is the difference between a thread and a task? So I assume you're probably going to speak to that in this.
So the question is, what's the difference between a thread and a task? And that's a fantastic question. So in both cases, they both use separate threads. The thing about a thread is if I'm going to go off and I'm going to do a thread on my own, I manually have to spin that up. And I can actually go in and spin up as many threads as I want, even if that happen to be more than the number of cores. And what's going to happen behind the scenes then is Windows would then kick in and start using time slicing, which is not necessarily efficient. On top of that, when I go in and I spin up a thread, that starts to give me a lot more power than I necessarily need. So tasks help simplify that. That with a task, what I'm going to do is I'm basically just going to say to the runtime, here, I've got something that's going to potentially take a little while. I would like you to handle this for me. And so it will go in and manage my threads for me. Because building up, tearing down a thread, very expensive. It'll automatically do pooling for me. Yeah, there is a thread pool that's available that I could go off and use, but this is going to help simplify it. It's also going to automatically spin up the number of threads that it thinks is going to be ideal, that it thinks is going to work. So that way, one more time, I don't have to worry about it. On top of that, tasks also make it a little bit easier for me to just go in and write my code in general. I find it easier to go off and create a task, especially when I'm pointing to a method that's going to return a value or a method that's maybe taking parameters, than working with a task instead. So Behind the scenes, they're both still going to use threads because the only way that Windows is going to be able to do something different at the same time is by utilizing a thread. So they're still using threads. A task is just simply a container or a wrapper around that that's designed to help make that a little bit easier.
Yeah, and I would add that it's a more declarative, or it's a way of giving your intent to the compiler. This is essentially what I want to do, and then allowing the framework, the .NET framework, and even the hardware to optimize in various ways, and then it knows your intent. If you get into specifically and imperatively saying do this and then this and then this, then the compiler and the hardware has really no other choice other than to do exactly what you told it to do.
Exactly.
But if you work at a higher level of abstraction and you just say, I have a task, go for it, you throw it to the task pool, then it can handle that in whatever way is optimal.
Exactly, yeah. Because if I say, hey, go create 10 threads, you know what the runtime's going to do? It's going to create 10 threads because that's exactly what I told it to do, regardless of whether or not I actually need it. And a lot of times you wouldn't. It sort of goes back to the early days of .NET, and people started wondering, oh, well, I really want to maintain my own memory. No, you don't. No, you don't. Let the garbage collector take care of it for you. And the same concept here, I really, really want to maintain my own threads. You probably don't. There are going to be scenarios when, yes, that's absolutely what you're going to need, that you do need control over that and so forth. But the vast majority of the time, we don't need that level of control. So let's go ahead and take a look at concurrency here. And what we're going to notice with concurrency is that concurrency is going to mean the parallel object. That concurrency, again, kind of steps up from our tasks and basically gives us the opportunity to say, hey, look, I've got this over here. I need to do a lot of different methods. So maybe a whole series. That's when invoke comes into play. Or maybe I've got some form of a collection, and I need to perform some operation on each item in the inside of that collection, and I know that's going to take a little while. Let's just go ahead and pass that off to Parallel, and just let Parallel go do its own little thing, and let Parallel figure out how to best optimize all the threads that we're going to have. So let me go in and take a look at a demo here. Kicking back over to Visual Studio. There we go. And let's go ahead and scroll on down. And here's what I want you to notice, is I want you to notice that I've got my basic little for each here. Now you're going to notice here that I'm using the little stopwatch. I love the stopwatch.
Isn't it wonderful?
It is. That whenever if you're just trying to go in and play with things, or especially if you're anything like Jeremy or myself, that having to go off and do demos and trying to prove, hey, this is how long this took, that stopwatch is just perfect. So that way,
before the stopwatch, I was creating a date time and looking at the diff.
Exactly.
I don't want to do math. I'm a developer.
Exactly. Yeah. I've got better things to do with my time. Mad Men is coming back on the air. So in any event, what you're going to notice here is that I've got my little stopwatch that I've created. And then what I'm going to do is I am going to set this up with a little await task. So I am going to spin this off on a separate thread. So my UI is going to be responsive. But I want you to notice that I'm calling this little for each helper that we saw before, that's going to call modify member. And what modify member is going to give us is it's just simply going to add on to the little message property that so-and-so was modified on whatever thread they happen to be modified on. So that's basically my way of indicating of, hey, look, we're doing work on separate threads. And so when I go off and do that, Christopher, stop hitting Control F5. It's just, it's just ingrained into me. So when I go in and I do my little for each, even though it happened to be on a separate task, that one task contained the entire for each. So you'll notice that all of this came back modified on thread 4. So there was no actual separate threading because the runtime couldn't pick up on that. That all that it saw was that call to for each there. If I want it to be parallel, I just need to tell it, be parallel. And what you're going to notice is that, sure enough, there's a parallel for each. And then I can tell it, hey, this is the collection that I want you to go over. And there's the method that I want you to call. So again, just like before, it's going to do the exact same thing, one for each item. But this time, it's going to be able to spin that off on 2 separate threads. So now let me just do the for each again. We'll wait the few seconds for this to finish. You'll notice that that took 4.688 seconds. There's going to be a quiz on that time later. All running on thread 4. You're going to notice when I do the parallel for each that this time it used 3 separate threads and it took just under 2 seconds to execute. Now, what happens if maybe we're running a link query? And on our link query, we're going to use maybe a little method here that's going to tell us whether or not it's the member that we want. And so if I bring this back up, Alt F12, again, you're going to notice that I'm using the same syntax as before, my last name. This is actually my secret way of just keep eliminating Jeremy out of my list here. Sorry, man. But you're going to notice that this time I added sleep onto the top of that. So this little method is going to take a few seconds for it to execute. So let's say that I just went in and I ran this just like normal, that I just went in and I wrote my normal link query. So let me go ahead, Control F5, and let me hit Run Link. Give it a couple of seconds. And you're going to notice one more time that it found the 2 names, but it took just under 5 seconds for it to execute. I want to do that in parallel. And if I do that in parallel, all that I have to do is just add on the as parallel. That's it. And that as parallel will tell it to do exactly that. Run that as parallel. And now you're going to notice I go back, run plink for parallel link, and now you're going to notice that took just over 1.5 seconds and gave me back the exact same results. Again, without it, and again, with it. Just like that. So what I want you to notice out of all of this is the fact that .NET gives you a couple of different ways that you can manage your threads from a higher level, like we talked about, and it also gives you some great options for handling asynchrony and concurrency, just as JavaScript did as well. And I think that pretty well covers that.
It covers it. You nailed it.
Yeah, excellent. You know, with all this talk of chicken catch story, I got to tell you, I'm getting hungry. So what do you say we take a meal break, and we will come back in an hour?
Yeah.
Yep.
There you go.
All right.
Good.
We'll see you guys back in about
care.
an hour.